Hello, my name is Jim Snell, and my company, Rising Sun Imports, Inc., and GasGas USA, Inc., would like to thank you for the purchase of the GasGas product. This is your year 2000 maintenance video. The purpose of this videotape is to assist you on routine maintenance of your GasGas trial bike. GasGas USA and Rising Sun Imports have a large dealer network set up throughout the United States. These dealers are very well trained and will assist you in most matters concerning your motorcycle. We will show you at the beginning of this videotape some routine maintenance procedures which will help you to do your maintenance on your motorcycle easier and faster. This 2000 model GasGas trial motorcycle represents the 15th year of production for the GasGas factory in Spain. We have been importing these trials motorcycles to the United States for 10 years, and during this period we have found that there are some maintenance procedures that customers and dealers have some minor problems with, and we will focus on these at the beginning of this video to help you to do these procedures easier. This video will cover maintenance procedures on most GasGas Trial and Pampera models from 1994 to present. As these bikes change very little mechanically through the years, most of the maintenance procedures you will see in the video from prior years apply to this model also. If you're removing your motorcycle from the shipping carton and setting it up, please don't forget the front wheel spacer, which is in the wood skid base where the front axle attaches the motorcycle to the skid. It's inside the wood and you will see it in there, and it goes on the disc side of the front wheel. When installing the front wheel, you'll have the disc brake rotor on the left hand side of the bike, and the axle goes in from the right, and you put the axle through and it threads into the left hand side of the fork. It's a size 10 millimeter Allen, and when you tighten this axle, you do not want to over tighten it because that side loads the wheel bearings, so the correct tightening of the axle is just snug. Then you will bounce the bike up and down a couple of times, and then you tighten these two screws here on the front fork pinch on the right hand side. Do not over tighten these screws. This Allen is a size 5 millimeter. We've installed the front fender. This Allen is size 3 millimeters. Also, do not over tighten these bolts. Next, we install the foot pegs. You insert the foot peg bushing through the spring. After you've put the spring into this hole on the peg, the bushing slides through, and the peg goes on the bike, and as you're pressing the foot peg down, the spring will be against the frame here, and you align the hole, insert the bolt. The Allen is size 6 millimeter. The nut is size 13. And you can tighten these foot peg bolts as tight as you would like because the bushing itself allows the foot peg to pivot freely. Elsewhere in this video, we will speak about using Never-Seize anti-seize compound on some of the bolts that go into aluminum. This is important, so please watch the video thoroughly, and when you get a chance, do that, and it will help you later on to prevent these bolts from sticking. On the Kickstarter, we have a special bolt. It's a Torx. It's a size 30. It's important to check this initially and to check it frequently throughout the life, as the use of the Kickstarter applies quite a great deal of force in this area, and these bolts must be maintained and kept tight. And the size 30 Torx goes in this bolt, which is to tighten the kickstart lever to the shaft, and then the same bolt on top. And keeping this tight is relatively important. Periodically spray a little spray lubricant in here to keep this kickstart mechanism working freely. This bolt here is where you put in the oil into the transmission. and the oil level is checked on the sight window, which is on the side of the case here. The bikes are delivered without oil because of shipping requirements. If it's been set up by your dealer, it probably has the oil in it. If you're setting it up yourself, be certain to install 650 cc's of 5W30 or 10W40 normal automotive motor oil. Please don't use a synthetic motor oil in the transmission, as it may cause the clutch to drag slightly. Another oil that you can use in your transmission clutch is Dexron 3. For the year 2000, we now have a drain plug on the cooling system, this being the lowest point in the system. You can remove this Phillips screw and you can catch the water antifreeze mixture as it's draining out of the bike. It would be necessary to also have the radiator cap removed from the top of the radiator. For the year 2000, we have a new redesigned air box, and to service the air filter, you will remove the 2 screws on the air box lid, and the lid removes, and the filter is there. Very similar to the filter you'll see elsewhere in the video. It's important when your bike is brand new and you're first setting it up to look inside your air box and make sure there's no manufacturing debris of any kind. If you wish to remove your air box to do this procedure, anytime you would put the air box back on, one hint is that you take an X-Acto knife and you cut a little bit out of the interior of this hose just to dull this edge, and this allows this rubber hose to slide onto the carburetor a lot easier. You'll find this plastic flap included with the motorcycle. The foam edge goes down and to the top. There's a screw at the back of the air box which you remove. Goes in that hole. The flap goes on the air box. And this flap on top will tuck up underneath a flap that's on the bottom of the rear mudguard. To install the rear mudguard or fender, we must remove these 4 Allen bolts. There's 2 on each side of the frame. Be careful not to dislodge these little spring clip nuts. The Allen wrench size is 5mm. Your rear mudguard, you have the plug-in for the tail light wires, and the bottom of the mudguard has a lip which tucks under the mud flap that we just installed previously. Then the mudguard goes down over these holes, and I recommend that you start each bolt and then tighten them after they have all been started. And if you don't have perfect alignment, you can insert your Allen wrench in there and wiggle this around just a little bit, and then you can line your bolt up just fine. On the right-hand side of the frame, there's this plastic protector above the foot peg. You remove 2 Phillips screws, and behind it are 3 hidden bolts. The top one attaches the center exhaust system to the frame, and the bottom 2 attach the rear brake master cylinder to the frame, which this is the master cylinder here. Beginning in '99, we have the 4 piston brake calipers, front and rear. The way that you change the pads is different than on previous models. We have a small mud shield here, which you just use a screwdriver and pry up on it, and it's held on by this little clip which goes over the shaft there. This special bolt that retains the pads to the caliper is removed with the size 3mm Allen wrench, and the threads on this bolt should probably be lubricated with a small amount of grease to prevent them from seizing or never seize. Once this bolt is removed, then you can take the pads out from the top. Now this works on the back or the front wheel, and this is a very easy procedure to change these pads, and you do not have to remove the wheels. Now if you're replacing worn pads, you may find it necessary before removing them to first place a screwdriver down in between the pad and the disc and press the pistons back into the caliper. This will allow your new thicker pads to install in there. As the pads wear down, the pistons travel farther and farther out, so it's necessary to press them back in when changing to new pads. Do not over-tighten this bolt. The aluminum fuel tank is different for the year 2000. To remove the fuel cap, you flip up this lever and you turn it 90 degrees, and then the cap removes. And press down to lock the cap in place. The cap, this area of the cap must face forward. It's a size 4mm Allen, which you remove this bolt from the front of the tank and you unplug the fuel line, and the fuel tank comes off without removing the seat or the rear mudguard. It's best to wash out your new fuel tank, also again to check for any manufacturing swarf. You also want to make sure that this bleeder nipple is free so that air can pass through it, and also check on this vent hose. Here is a one-way check valve. If you suck on the hose from this end, it's free. If you blow into the hose, you'll find that it's obstructed. This prevents the gasoline from coming out through the vent in the tank and coming down through this hose. It is necessary, though, that the hose be able to breathe air in as the gas is depleted in the fuel tank. If you're setting the motorcycle up from new, it may be necessary to change some jetting inside your carburation. This is the carburetor here, and elsewhere in the video we discuss the jetting. Your local dealer can help you with this, and the jetting will need to be set up for the area or altitude and weather conditions where you live or where you're riding the motorcycle. When installing the handlebars, we find that these handlebar clamps, which we discuss elsewhere in the video, but have an offset, that the offset be towards the front so that the handlebars are in the forward position. And also we find that the handlebar position works best if it's vertical with the ground. So with the bike sitting on the ground, the handlebar should stand straight up. The crossbar on the handlebar will basically overlap the top of this bolt, be in the same plane as the top of this bolt. The hydraulic fluid that's installed in your hydraulic clutch and your front and rear brake systems by the Gas factory in Spain is DOT4. You can also DOT 5. It's available from auto parts stores nationwide and even at the department stores in the automotive department. I'm going to show you a few little tips about bleeding these systems to remove the air, make this a lot easier. I went to a farm store. Now, these may be available in your region or may not. Here in Indiana, we buy these at the farm store. It is a veterinarian syringe. On the end here where the needle goes, I've installed a rubber hose. Now, you'll draw the DOT 4 or 5 fluid up into the syringe from the fluid container, and this way you can inject under pressure the fluid into the system. This works much better than the pumping of the lever or the pedal. This is very quick and very easy. On the rear brake, the way to bleed it we find best is to remove the inlet fluid hose, which this comes from the reservoir, so this is not under pressure. So I pinch it off with hemostats and remove it. Then I plug into this nipple here on the master cylinder with my syringe. Then I open the bleeder nipple on the rear caliper and attach a bleed hose which goes to my small jar. And when I open this, I can inject the fluid in through this nipple here, and the fluid goes through the brake system, fills the caliper, and comes out through the bleeder nipple. Now, if you use a clear hose on this end here, you can see when the air bubbles have stopped coming through the hose. And then while still maintaining a constant pressure on the syringe, close the bleeder. Now, if you run out of fluid when you're near the end of your travel, keep the wrench on the bleeder and close it. then you can get more fluid and do the procedure again. Now on the front brake and the clutch, you want to also inject into the front brake caliper on the caliper itself with the cap removed from the master cylinder on the handlebar. You will see the fluid rising up into the reservoir, and be careful because if you're pressing hard on this caliper, on this syringe, the fluid will shoot out of the master cylinder and hit the ceiling. But air naturally wants to rise in the system. So when you're bleeding the clutch or the brakes, when you're pumping with the lever from the handlebar, you're pressing those air bubbles down through that hose. But then when you release that lever to get the next stroke, those air bubbles naturally rise back up again. So you're moving an air bubble back and forth, and you don't really get much done. When you inject the fluid from the bottom, it forces all of the air that's in the system to rise, and it comes up out of the top of the reservoir, and you'll find that your bleeding procedure is very quick, and you'll have very solid brakes. The bleeder nipples on the front and rear brake calipers are size 11, and the one on the clutch slave cylinder is a size 7. And you can see I'm keeping the wrench on the nipple, and there I insert the syringe, and when I open the bleeder I can begin to inject the fluid. Now again, with the cap removed from the reservoir on the handlebar and with the reservoir drained, and one way to drain it is just to sop up the fluid with a rag. And if you're going to change the fluid completely, it usually takes about 3 syringefuls before you have completely evacuated the old fluid from the system. So it will be necessary to repeatedly drain the small reservoir on either one of the handlebar units. When you first assemble your motorcycle, you may wish to take the time to add some additional grease to the wheel bearings on the front and rear wheel. You can do this by using a small pick instrument to remove the wheel seal, and then you can add the grease and then press the seal back in place, and it's done like this. You put the instrument very carefully under the edge of the seal and pick it up. You can see that it comes right off of the bearing. You can see this original bearing here has very little grease. This is just the way that they're produced. So you're filling this area with grease, forcing it down in there, then you put the seal back in, and then take your rag and wipe off what grease oozes out, and you have your bearings super greased. Okay, so we're going to change the back tire. The first thing we've done is removed the valve stem so that the tire has no air in it. Now if you remove the stem, then that allows the tire to flex when you're trying to remove it. So that is necessary. I've placed this wheel on a wood block, and the back of the rim is supported under the block. This prevents damage to the sprocket or disc on the ground. Now, some of you may have a nice bead pinching tool which takes the bead loose from the rim. But on the rear wheel, this is tubeless, so it's similar to an automobile tire. You have a type of bead design which seals very tightly to the rim. Now, a field method that I find works pretty good is the wood block here. And you have to kind of be careful, but if you're wearing your work boots, you can stand on the wheel like this, and you can put the heel of your boot right against the tire, and pressing down, you can get it to break loose. There. Now it's just a matter of pressing the tire all the way around to get the bead loose. And of course we'll have to turn it over and break it loose on the other side by the same method. There. Okay, now the deep center of the rim. Okay, you must have, when you're removing the tire, first I'd recommend that you start removing it at the valve stem. You have to have the bead on the opposite side up into this deep part of the rim. And when you do that, you can see there, that's where it's at, then that makes more space on the opposite side where you're using the pry bars. I have tire tools available at motorcycle shops nationwide. I have water and dish soap, about a 50-50 mixture. It's very slimy. I'm going to go ahead and soap up this tire a little. Makes removal and installation a lot easier. And so with the hooked end of the tire tool, I'm putting it in here. You have to be careful not to nick the sealing band that's inside this rim. Okay, now I'm again making certain that the tire is inside the deep part of the rim on the opposite. And then I've started it. Okay. You can actually put your tool under the sprocket. And then it's very easy to dismount the tire. At this point, it comes right off. And repeat for the other side, and then the tire is removed from the rim. Always, you have to remove both sides of the tire off of one side of the rim. Now, these Performance Trials tires, when you're reinflating them from a flat or if you made a repair, sometimes it's difficult to get them to seat. I'll show you a little trick with a bicycle inner tube. Okay, so the bead won't seat. This tire won't take air. There's too much of a gap, okay? This is the problem with the rear tires when you're remounting them. So I've lubricated the tire all the way around. I have, from the local discount store, a bicycle tube, size 20-inch. I've inflated it with just enough air that it becomes its natural shape. Don't worry about the valve stem. You just put it there, and you put this inner tube in here like this. Always the lubricant is very important. Okay, I have it completely tucked in all the way around, and I'm just going to add my air, and the tire is going to seal. Sometimes it takes a couple of tries. There we go. And the tube begins to pop out. And then we can pull the tube loose as we're doing it. Okay, now we've pulled the tube out, and we can give the tire one last shot of air. We want to make sure that the bead seats all the way around. It's going to give you a big pop when it comes up on the other side there. These tires can hold a tremendous amount of air. There we go. Then, of course, we're going to return the tire to the correct pressure, which is 5.5, 6 pounds for the normal riding conditions. If you should puncture your tubeless rear tire, you will find at the discount stores nationwide in the automobile department or from your auto parts store a tire plug kit consisting of the little tool which you insert in the puncture, and then you have these plugs. They're very sticky, and you put the plug on this tool and you just insert it. If it's a thorn or nail puncture, you just insert it in the puncture itself, and then you trim off the excess plug that sticks out of the puncture and put more air in, and you're fixed. On the front tire, it has a conventional inner tube like a bicycle, so it would be necessary to replace the inner tube or to patch it. Also, you would have to be certain that you had removed the thorn or nail from the tire carcass so that your new tube was not damaged. The way that your rear wheel retains the air inside the tire is through a sealing band. This prevents the air from leaking around the spokes. The sealing band here installs with the same soapy water method. It's just virtually impossible to install it dry. You would start by putting the valve stem piece in first, and if you have this apart, be very aware of the components of this valve stem. There's a small spacer that goes underneath here to keep this stem from compressing too much the rubber band. And after installing the stem, then you can put the band on the rest of the rim using, again, lots of soap and water. That works best. That allows the band to squirm around and find its own position. And sometimes you'll have slow leaks in your tire related to this band being damaged or out of position. Like I said earlier, it's possible to damage this band or to move it when you're using your tire tools, so be careful about that, especially if you're going to use screwdrivers or something like that instead of tire tools. The rear shock dampening can be adjusted with a size 7 metric wrench. You can lay the bike on its side, and then it's very easily accessible. When you turn this screw clockwise, you add dampening to the shock. The factory sets the suspension up very fast. They come in the fastest position. On the top of the front suspension fork legs, you'll find little adjuster knobs for dampening. The one marked E, which is extension, is the dampening adjustment for when the fork is snapping outward. This slows down or speeds up the outer travel of the fork leg. The one marked C, which is compression, is the one that affects the dampening when the fork is traveling upward. And the plus on the little knob means you're adding dampening or slowing down that action. Minus means you're making it quicker. When you're removing or installing the rear wheel or making a chain adjustment, you may find this elsewhere in the video, but we wanted to show you a little trick. We need the adjustment to be where this rubber tensioner block almost touches the swing arm. Now, when you're looking at these cams, there's marks on them, but I find the best way is just to look at the bike from the rear, and when you're standing behind it, you can see very plainly that both of the cams are in the same position. Before I tighten the axle nut, I always put a screwdriver or a large Allen wrench in the chain, and I pull back on the wheel, and then you can see what it does here. It's tightening up the whole drivetrain, which pulls the wheel tight forward against the stops here. This gets the whole wheel tightly pinched to the swing arm, and then while under this tension we can tighten the axle nut. This needs to be fairly tight. Okay, and then when we remove our tool, we have the correct adjustment, the block almost touching the swing arm. As the swing arm goes through its travel, this block will move up and down as the chain goes through its arc. You may wish to remove the electrical wiring harness for the lights. This can be a difficult procedure. It's probably best just to leave the wiring loom alone, but if you want to remove it, there's two different ways you can do it. Number one would be just to cut off the part that goes back to the tail light and to the rear brake light switch, etc. But if you're going to do that, you would need to decide whether you want to retain the electricity from the pickup for the speedometer drive, which is on the rear wheel. You must separate those wires from the main loom if you wish to retain the usage of the speedometer. Here you will see the back part of the wiring loom. This being the wires for the rear brake light switch, which is by the rear brake pedal. This is the tail light wires. This is the wires for the speedometer. So it will be necessary to use an X-Acto knife and to open up this wiring loom entirely to separate the speedometer wires. At which point then you can cut away the other wires up here in this area. I'll show you about cutting off the wiring loom. It's probably best after I've got one for an example here. I've opened it with the knife. Have the wires. When you're cutting off some wires and taping them up and setting them aside, it's best to cut them in series like this, so that if you cut them directly across, then it's possible that when you tape them up, you'll have a short there. But if you cut them like this, then when you tape them, they won't come in contact with each other. And then thoroughly electrical tape this area and put it somewhere where it's out of the way so it doesn't get against the exhaust or the chassis anywhere. If you wish to remove the large light switch from the handlebars and install an accessory ground type kill button, the kill button wire from the switch to this plug-in is the wire that's green with a black stripe. It exits this plug-in as black, and the ultimate destination of the kill button wire is the ignition control advanced module, or black box. Has this type of a plug-in. This white wire with the bullet type connector is the kill button wire. So you would attach your wire from your accessory kill button ultimately to this bullet connector that comes off of the pigtail from the black box or ignition control advanced module. The ignition control module or black box is located in the very front of the frame underneath, and you can see here is the kill button wire bullet connector with the black wire plugged in. You can attach your kill button here or behind the headlight where the black wire comes into that plug-in. This module here is the DC converter. It turns AC power from the stator into DC power to operate the electric cooling fan, which is right here. That's the sole purpose of this module. The modules I'm holding in my hand, the small one here with one yellow wire, is the voltage regulator. This takes out excess AC voltage to prevent you from burning out light bulbs, etc. And like previously explained, this controls the advance of the ignition system. This being the coil. There are two types, this type and the type here that's shown on this motorcycle. They operate the same. Okay, so you want to remove the whole light wiring harness. Put a number plate on the front. You want to use this bike only for competition. This is when we have to really pay attention. You have to think about this and follow our steps carefully. If you don't feel competent to do this, please don't attempt it. But it's really not too difficult if you're aware of what you're doing and you pay attention to the details. We'll look down here. I've taken the knife and opened the loom. This is the part from the tail lights. On this bike, I'm going to eliminate the speedometer and everything, so I haven't had to separate it like I explained earlier. Okay, this red is your main AC power in the motorcycle. Here, this pigtail coming up with a light blue, a dark blue, and a yellow is your AC and your ignition coming from the stator. This wire comes up the frame, up by the side of the radiator from down on the magneto on the side of the engine. This being your AC power in. This is AC power going in to this big connection. This red wire here that goes in here with this little blue one, you can see is going down to the thermostatic switch on the fan. It's necessary that that be kept in the system. You need power to this switch, and then the power goes through the switch and comes back to the little converter and makes the DC power to make the fan run. Then we have over here the voltage regulator. It has the yellow wire there. This one also needs to be retained. So here we have the power in, power to the thermostat, power to the regulator. The rest of this is going out to the lights. This one that goes to red and blue, similar to the thermostat, is the horn that you've disconnected earlier. So we're just going to snip away from this connector the red wires that are going to the horn and out into the wiring loom. Now here we have our kill button wire, so we have our little bullet connector we talked about earlier, so we're just going to pull it loose. There we have the whole light wiring loom removed, and with one very simple little cut. Now we will very carefully, as this is AC live power, we will tape this really good with some electrical tape, and then we'll plug in our accessory kill button here on this bullet connector that we spoke about previously, and that's it. You may notice the Hebo stickers on your bike. Hebo is a company owned by GasGas. It's the largest distributor of trials-related accessories in the world. Many of the little products on your GasGas are made by Hebo, or in Spanish, Ebo. You can look at Hebo products at your dealer with the catalog, or you can see Hebo products on the World Wide Web at hebousa.com. You'll find that the foot pegs on your bike are a Hebo product, the handlebars, the brake calipers, and brake pads. Hebo manufactures all types of clothing for trials, trial boots, gloves, helmets, helmet cleaner, bar end plugs, protectors for heat on your exhaust, tool bags, bags for equipment, bags for boots, excellent coats, waterproof coats with removable sleeves. There's a full product line with the GasGas name for your motorcycle, available through your GasGas Hebo dealer. The new Pampera has a completely new chassis and all new bodywork. Mechanically, it's very similar to the previous Pampera model, except for the fact that now it features an expansion chamber type exhaust system to enhance the performance of the engine, and slightly different ratios internally in the transmission. The new Pampera also features a redesigned muffler silencer. It also features a battery this year and a mechanical speedometer odometer with a key ignition switch and locking steering. This side cover is removed by removing the screw here at the bottom and the seat bolt attaching screw. You will see the battery. It has a fuse for the battery located here. This is the rear brake fluid reservoir. This is the overflow reservoir for the radiator. When the bike gets extremely hot, the radiator overflows into this bottle. By removing the same two bolts on the left side cover, you can gain access to the air filter. The air box lid removes by the same method as on the Trials bikes, with the same filter. After removing the two bolts at the back of the seat is lifted at the rear and pulled backward. And as you can see on the seat, there's a slot here. This goes in this bolt on the tank. Also, this bracket here slides into this opening on the seat itself. So when we're installing the seat, be certain that you have the front and this in the proper location by pressing down and forward. It's necessary to remove the fuel tank. You will find a mounting bolt at the front of the tank here, an Allen, a rubber strap which is released here at the back of the tank. Then in the front you will find Allen head screws, 4 of them, 2 on each side, which must also be removed. Then the fuel tank and the radiator side covers all come off as one unit. During normal maintenance, it may not be necessary to remove the fuel tank, excepting when you are wanting to check the coolant level of the radiator. The spark plug is accessible easily from the left side of the motorcycle without removing the fuel tank. After removing the cardboard wrapping from your shipping carton, you will find your new GasGas anchored to the wood pallet. The front axle inserts through a wood block on the pallet, and you will find inside that wood block your front axle spacer. You'll find the handlebars and front brake packaged like this, the foot pegs and the fenders and the front wheel. Attached to the inside of the cardboard shipping carton, you will find these 3 booklets. This is the owner's manual. This is a warranty booklet that's used in Europe but not used in the United States. You may discard this. This is the owner's manual for the little computer, which is on the fuel tank, only on the 250 models. Before we begin to assemble the motorcycle, we will remove the fuel tank cover by removing the gas cap, and you rotate this D-ring. You will notice that the odometer and stopwatch timing device will come off with the tank. This wire right here plugs in to a wire that's furnished right here at the back of the fuel tank. This is the plug-in for your odometer, which is connected to the rear disc. The fuel tank removes by pushing forward on this rubber hold down and releasing the fuel line from the petcock. Pushing backwards on this, you can then lift the tank up and out. After removing the fuel tank, you will find most of the components of the motorcycle accessible. This is the ignition coil and black box module. This brownish red box is the DC converter for the cooling fan. This is the thermostat, which operates the cooling fan. Your spark plug. This is the fan and motor itself. This is the filler for the radiator. This silver box is the voltage regulator, which regulates AC current coming from the magneto, and it's found right in there. You will notice on the 95 JT25 model, this additional line right here, which tees into the water hose on the opposite side. The JT25 model for 1995 has incorporated liquid cooling into the center cases. You will also notice on the 95 JT25 this small electrical pickup and this small magnet. This is what operates the odometer speedometer mechanism, which is in the fuel tank cover. The wire is conveniently located through the inside of the swing arm. This is the new banana-shaped swing arm. It has a much more accessible linkage area. You can now work on all of the linkage bolts. The kickstand has been moved back slightly, and they have allowed for a larger clearance in the rear brake master cylinder. Also, they've redesigned the rear brake pedal. Also on the 95 bikes, you will find an oil level sight glass. This tells you if you have the proper amount of oil in your transmission and clutch. This was formerly the spot where you filled the oil. Now you fill the oil here. Also for 1995, the wheel spacers now insert into the hub so that you may remove the wheel and the spacers remain intact. The front and rear wheel are like this. Also for 1995, they have redesigned the chain tensioner and added a much more rugged tensioner block. This part also interchanges to the older model gas gases. We recommend that before you attempt to assemble the motorcycle, that you grease the upper and lower steering head bearings, for the simple reason that when the motorcycle is disassembled, when you first remove it from the crate, it's very easy to take apart this and thoroughly grease it. This will prevent problems later. Here we have a steering stem. This small bolt must be loosened to release this nut, which unthreads from the steering stem shaft. And then after loosening the two front pinch bolts, you can lift the entire top of the steering stem off, and then you remove this flat nut and the steering stem comes out from the bottom, and you can grease the bearing, which is here, and then there is also a bearing that is at the top. After we've loosened all these bolts and we've removed this nut, we can then remove the top triple clamp. This nut here we then remove, and it will allow us to drop the forks down slightly. You may find that you can just loosen this nut to the top of the threads, and it allows the fork just to drop down enough where the bottom bearing can be greased without the removal of the entire assembly. Allows the forks to drop. There's the lower bearing. As you can see, it's greased from the factory. Take your grease, apply it to the bearing. There's the top one. There's an O-ring at the bottom and the top to seal the bearings. Be certain that they're properly installed in the groove that's designed for it.
When reinstalling this nut, it should just be tightened by hand. And you can take a rag and then check for free operation of the fork. And also check for play. This should not be over tightened. You want the forks to move freely. Before we reassemble the forks, we recommend that an anti-seize lubricant be applied to the threads. This will guarantee that the aluminum nut does not seize to the steel shaft. We must also be certain that our surfaces are clean on the fork and inside. This is where you clamp, and if this has grease, then the forks can flex because there's not a good mount there to this clamp. We want this nut to be very tight. This bolt locks this nut in place so it cannot come loose. Any bolts that you're going to install into an aluminum part should have never seize applied to them, as steel bolts have a tendency to seize into aluminum. We will also never seize the triple clamp bolts. When reassembling, you want to first tighten the flat nut. Do not over tighten this. You want your steering to move freely, but it must be tight enough so that there is no play in the bearings. Then you tighten the top nut. Then you tighten this jam bolt. Then tighten the two front pinch bolts. Factory recommends 5 millimeters of the fork tube be above the top edge of the top clamp. When you install the handlebars, you will notice that the handlebar clamps are offset slightly. This is installed in the rearward position, and by reversing the clamp, you can move the bars forward. We recommend that the handlebars be positioned so that they're standing vertical, and another good guideline is that your Allen wrench touches the crossbar. You should also make sure that you have both sides of your pinch clamp evenly tightened. The throttle cable is installed by inserting the ball end in the grip when it's rotated. It must be on the little wheel. Check for free operation and that there's very little play. The clutch and brake master cylinder are very similar in design. You will find a small screw here. This screw adjusts the lever position. Then you'll find a jam nut, which uses a size 10 millimeter wrench, and a small Allen. This bolt with a jam nut adjusts the blade free play. On the clutch, you should have almost no free play. And on the brake, you should have about 10 millimeters of free play. The internal parts inside the clutch master cylinder and front brake master cylinder are identical. Later on in this video, we will discuss the repair and maintenance and diagnoses of problems that you may have with the operation of these master cylinders. After every ride, especially after vigorous competition, you should always check the level of the antifreeze in your radiator. This is an automotive type cap. You remove it and you should see the antifreeze visible in the neck of the radiator. Use a 50-50 mixture of automotive type antifreeze and distilled water. The spark plug has a recommended gap of 20 thousandths of an inch or 0.5 millimeters, a Injicate BP5ES or a Champion N11YC is suitable. The rear brake fluid reservoir is located here behind the carburetor. It should be only half full. This allows for the expansion of the fluid when the rear brake gets hot. This gray tube with the spring is the crankcase vent. It should be kept clear from the exhaust system and make sure that it's not obstructed on its end. To service the air filter, you should remove the screw which is at the back of the fender underneath. Looks like this. It has a small flat washer. You can tilt the fender. You can use an open end wrench to release the strap which holds the air filter lid. This is the filter element. It's greased with filter oil from the factory. When you attempt to clean this filter, do not use gasoline or any other volatile solvents, as it may possibly dissolve the glue which holds the filter together. Soap and water is recommended. Let the filter dry in the air or in the sun and treat it with any quality filter oil designed for foam filter elements. To reinstall the filter, same procedure in reverse. If you have large hands, it does work better with the wrench to help you to install the O-ring. Put the fender back down and make certain that the fender, its lip here, is behind this mud shield. Reinstall the bolt. When changing the motor oil, you will find that the drain plug is in the skid pan. It's the hole that's to the rear. The front hole in the skid pan is to drain any water that may be in the crankcase if the bike is submerged. After draining the oil, and when you're going to refill the oil, we recommend that the bike merely be laid on its left side. Then you can insert a funnel in this oil filler orifice, and we recommend 650 cc's to 750 cc's of any quality automotive motor oil in a weight of 5W30 or 10W40. Pennzoil, Quaker State, Kendall, any of those type brands are suitable. Before operating the motorcycle for the first time, you should tighten the spokes. We recommend that you start at the valve stem. This gives you a reference point so that you'll know when you've been all the way around the wheel. The spokes on one side of the wheel and on the opposite side of the wheel differ in length, so therefore their tone will be slightly different. But a spoke which is tightened properly should emit a musical tone similar to this. If the spoke is too loose, it will sound dull when you tap on it. Another way to check for loose spokes is to flex them with your hand. The spokes should also be checked again after a period of operation, as they may tend to get loose over a period of time. During the initial setup of the bike, we recommend that you check every nut and bolt on the machine to make sure that they're tight. The skid pan nuts, the 6 bolts which hold the rear sprocket to the hub, those should also be checked periodically. You may wish to remove some of the bolts from the engine and treat them with an anti-seize lubricant so that if you ever need to take apart the engine later, the bolts will not be seized into the aluminum. We recommend that the bolts which attach the subframe be installed with Loctite, as they tend to vibrate and loosen. The rear suspension bolts should be checked every time you ride. They must be very tight. This large bolt uses a 17 millimeter wrench. This is a 13 millimeter wrench, and there are also 2 bolts with 13 millimeter nuts at the front of each of the connecting arms on the linkage. You may need to partially disassemble the linkage to gain access to the bolt which is attaching the bottom of the shock absorber to the linkage. This completes our setup portion of the owner's manual video. We will now discuss some of the maintenance of the chassis and engine of your new gas with basic hand tools. Now we will discuss the operation of the AJP brand hydraulic master cylinders for the clutch and the front brake. This is a front brake master cylinder. To take this master cylinder apart for maintenance, you remove it from the bike. You will remove the bolt that the lever blade pivots on and set the blade aside. You may wish to remove the lid and the baffle. You will find this rubber boot, which merely you pull on it, it comes off. It contains a small push rod with a spring. Be careful not to lose these parts. If you have a problem with your master cylinder and you believe maybe that the piston is not working properly, you can remove this rubber boot from the part and set it aside, reassemble it using these components, and then you can visually inspect this piston for smooth operation. You will find a circlip, which you will need a circlip tool to remove it. The piston, which is spring loaded, can be easily removed. Inspect the two rubber O-rings for damage. You should also inspect this spring, and this spring may need to be replaced periodically, as they do tend to become compressed over a long period of time, and this will cause your piston not to return fully to the circlip, which acts as the outermost stop for the piston. This small hole inside the master cylinder reservoir is where the fluid passes from inside the reservoir down into the piston. It has a very small orifice. You can see a fine wire will insert down in there. Be certain that this is not obstructed if you're going to do a teardown on this part. The reason that the spring may be a problem is if this spring becomes collapsed, which you can see by comparing to a new one, it will prevent this piston from returning all the way to its stop, which is this circlip. This prevents fluid from passing through this orifice into the hydraulic system. It may be difficult to bleed the system, or the clutch or brake may not work properly if this spring becomes collapsed. We find when attempting to bleed the air out of the hydraulic systems, front brake, rear brake, and clutch, that it's best done from the lowermost point, forcing the fluid into the system, which helps the air to rise to the top. This is the bleeder nipple on the front brake. You first will remove the cover from the front brake master cylinder and the baffle. You may wish to drain some of the fluid so that you don't overfill the master cylinder. You can purchase one of these syringes from most motorcycle stores nationwide. The company that offers this particular one is Tucker Rocky. It's under $10. You draw your brake fluid into the syringe. You place a wrench on the bleeder nipple. You install this flexible hose, and when you open the bleeder and very carefully insert the fluid by using the syringe, you will watch the fluid rise in the reservoir out of the small hole right there. And when no longer air bubbles appear, you will have removed all the air from the system, and you should have a good feel to your brake or your clutch. Your clutch bleeder is here. The same tool works to bleed the clutch. And as the fluid is forced in from the syringe, the air rises through the hose and comes out on top in the reservoir. The rear brake bleeder is here, and you may wish to push the fluid through from this end, Again, removing the cap from the rear brake reservoir, which is behind the carburetor. This allows the fluid to move through the system and rise in the reservoir without obstruction from the sealed cap. A few words about the conventional forks used by GasGas. This fork tube, which is the right side, controls the rebound dampening. The left leg, which uses the spring, also controls the compression dampening. To replace the fork seal, you will find this method that we use to be very easy and convenient. First, you must drain all the oil from the fork tube, and you can remove the internals of the fork by removing this large Allen head bolt from the bottom of the fork leg. That releases the internal dampening mechanism. Collapsing the leg fully, and on the left leg, which is the one with the spring, you will remove the spring and also collapsing it fully. You will remove your dust boot, and we recommend that these be replaced also with the seal, as these perform a vital function of keeping the seal free of debris. You will find a small inside snap ring, which you can remove with a small screwdriver. It looks like this. A very simple tool to remove the seal can be devised with simple PVC pipe, available at any hardware store. This larger diameter pipe is used to drive down this collar, which will force the seal upwards. There's your seal. You can remove it right like that. We recommend that you use the old seal as a buffer between the new seal. When you want to reinstall your new part, you pull on this collar to reset it. You will feel it snap into place. Then take a screwdriver, very lightly, pry apart this clamp and raise it so that it is flush with the collar. Install a bolt and nut to clamp it in position. This prevents the collar from sliding back down when you're installing the new seal. Very lightly tighten that. With your new seal, place it on. And with a smaller portion of PVC pipe, which you may have to have slightly turned down. There are other methods to do this, but this seems to be the best that we've found. You can see that it fits inside the collar and drives the seal back in place. It may need to be tapped with a rubber mallet. Okay, once you've driven the seal into position, reinstall your circlip. Be very careful when you're working with tools around your chrome fork leg. You would not want to scratch it, which would cause your new seal to rapidly wear. Being certain that your circlip is installed all the way down into its groove. There. Reinstall your new dust boot. Get one edge underneath, get it started. You can work it around. Okay. Remove your bolt and nut. And again, very lightly prying, you can move your fork brace clamp back to its groove. Okay, now, when you're going to reassemble your fork, you want to inspect your copper sealing washer on the bottom of your bolt. You'll insert your dampening mechanism into the fork and the bolt, and this bolt must be very tight so that you get a good seal at the copper washer. Then you can fill the fork with the two methods. The one method is recommended in the printed owner's manual, and that is to measure the distance from the top edge of the fork to the top surface of the oil, which is explained in the owner's manual. That is with the forks compressed. That is with the spring removed from the left fork and with the dampening mechanism pulled all the way up in the right fork. The other way to replace the oil in your forks is by using a graduated scale and putting a specific amount of oil in each leg. Those figures are: in the left leg, install 330 cc's of 7.5 weight fork oil, and in the right leg, install 280 cc's of 5 weight oil. On the new type forks, on the 95 gas bikes built after January 1st of 95, we find that the procedure for changing the seal is different. This collar that on the other fork you pressed downward, now this unscrews from the fork leg. It may be possible for you to just grip this with your hand and loosen it. As with most threaded fixtures, clockwise it goes on and counterclockwise removes it. If this is too tight to loosen just by hand, you may wrap it in duct tape and be able to grip it, or you may use one of those cloth oil filter wrenches which wraps around and works that way, or ideally you're going to use a spanner which is designed to insert into these holes which are provided. This wrench inserts in the hole and grips, and then you can loosen this collar and it just unthreads from the fork leg. It has an O-ring up inside it, so there's no need for any sealant. The O-ring comes to a stop at the bottom and seals this collar to the leg. When it's loose, then you can just draw it right off the top of the fork, and the installation is in the same procedure. Now, once you've removed it from the fork leg, you can remove the seal and change the seal or clean this part without the threat of damaging the chromium leg. Here we have the collar. After removing the dust boot, you will see a snap ring inside, and you need to remove this to remove the seal. After removing the snap ring, you can pull the seal out. As we said previously, we're trying to do these repairs using simple basic tools that a person would have, and I have this angled screwdriver here. This works very well for removing the seal. You put it under the lip and just rotate the screwdriver and the seal comes right out. Or very carefully you can use a screwdriver like this one and go like this. Of course, you are going to damage your seal when you're removing it, but we're assuming that you're going to replace the seal. So there we have it. This little ledge in here allows you a surface to pry against when you're removing the seal. Very nice. Here is the O-ring which seals the collar to the fork leg. A word about the seals. First, if you are replacing the seal, it's best to also replace the wiper, as this wears rapidly from abrasion on the fork leg. It travels up and down the same as the seal does. This is what wipes away most of the debris that can get into the seal. Oftentimes the seal that's leaking is not actually defective. It may have a small piece of debris underneath the lip which is holding it open and allowing the oil to escape. Many times you can just clean the seal and it will stop leaking. Also, a trick shown to us by Hap Oswalt of Harry's Trial Shop in California is to shorten this spring. This tightens the lip of the seal, which greatly reduces the leakage. Hap recommends that you do this on new seals also. The spring from the seal has a joint which is visible, and you just turn it and it comes apart. You'll find it has a male end and a female end. This original equipment spring, when we test fit it to the chrome leg, we will find that it fits rather loosely. We will remove 1/2 to 3/4 of an inch from this spring, from the female end. Then to reassemble the spring, you must first rotate slightly reversed. Join the two ends so that the spring has a nice even appearance when it's joined back together. We'll find now that this spring fits rather tightly to the chrome leg. Now what this does is it tightens up this lip on the seal. Reinstall the spring. And if you use a magnifying glass, you can inspect these lips, and if you see any damage at all on the seal wiping lips, then the seal must be replaced. Gas Gas has designed these new forks so that they're serviceable by almost anyone without any special tools, so that you no longer have to send the forks away or have them serviced by a professional. Another way to remove the spring to tighten the seal spring is, it is possible to remove the spring with a pick by just reaching down and never removing the seal from its collar, getting a hold of it like that, and just pull the spring up out of there. It's more difficult to reinstall it, but it is possible. Then you shorten it, and then you can put the spring back in. It is a little tricky, but it saves removing the seal, maybe taking the risk of damaging it trying to pry it out. In addition to the compression dampening adjustment, the new forks also use a spring in each of the two legs, where the Paoli conventional fork used one spring. To remove the dampening mechanism from either fork leg, you will find on the bottom of the leg an Allen screw. You remove this screw from the bottom of the leg, and you unscrew the top cap. The dampening mechanism can be withdrawn from the fork leg as a complete unit. On the bottom, be certain that this aluminum washer stays in position during reassembly. If it's not there, it will be laying in the bottom of the fork leg and needs to be removed so that it will not be improperly installed. Here we have the two dampening mechanisms from the right and left fork leg. As you can see, they are dimensionally identical, and they do interchange right and left for whatever purpose, I don't know. One is compression and one is rebound. Also, you may change the preloading of the springs if you wish. After a very long period of operation, it's possible that the spring may collapse partially. Or if you are heavier than normal, you may wish to preload the spring also. By removing the top portion, by unthreading it from this rod, there's a jam nut here. You can remove this, and the spring comes off. You will find that this is standard plastic pipe available at the hardware store. Has an inside diameter of 1 inch, an outside diameter of 1 1/4 inches. You can merely buy this pipe at the hardware store and cut a slightly longer piece and replace this with that piece, and that will preload your spring, making the fork seem stiffer. These new Gas Gas forks are very tunable. You can tune them virtually any way you like for your riding style and your body weight. The oil that is required and recommended by the factory is 5-weight fork oil and a quantity of 300 cc's each leg. You will find that since all the internal parts of the fork displace the same amount of oil, that each leg will now use an identical amount of oil also. Very easy to remember, a nice even number, 300 cc's, 5-weight. In very hot temperatures, or if you have different riding preferences, you may wish to switch to 7-weight. The oil should be changed in the forks every 3 or 4 months, or more frequently if you ride in extreme conditions. The screw for draining the oil from the bottom of the leg is located directly behind the center hole. Right there, it's a small Phillips screw. If you find any of these smaller Allens are difficult to remove, if you feel that the bolt is not going to loosen with your tool, a method of shocking the bolt with a drift and a hammer is recommended. While using eye protection, you take a drift, this being a bronze drift, and you apply it to the edge of the bolt, lightly tapping with a hammer. This will persuade the bolt to come out. This is the water pump cover. You remove 2 small screws. The cover comes off. You'll find an O-ring that seats in a groove in the case. This O-ring is many times reusable. This is the water pump impeller. You must remove this impeller to gain access to the seal. The impeller may loosen just with your fingers, rotating it in a counterclockwise direction. If it doesn't, you may tap it very lightly. The water pump is driven by a plastic gear, so don't force this. If it's stuck, then you may have to remove the clutch cover to remove the impeller, but the vast majority of the time, this impeller comes off with no problem. Behind it, you'll find the water pump seal. If the seal is correctly installed, you will see the spring on the seal visible. The seal must always be installed so that the spring is facing outward. This is the pressure side of the seal. Since the coolant system is under pressure, that spring side of the seal should face the water. You can take a flat blade screwdriver and put it in like this, and very gently you can pry and you can remove the seal, being careful not to damage the shaft or the case. And the seal can be replaced by placing the new one on in the opening and using a socket or any other suitable part that will help you to drive the seal in. If you want to inspect your clutch plates, you may just remove the 4 small bolts that hold this quick change cover. If you need to do any work farther in the engine on the clutch side, you may have to remove the whole clutch cover. To do that, you remove the kickstarter lever and the rear brake pedal assembly, which when you take this bolt out from behind the frame, the pedal will come out like this. You take out the 8 bolts that hold the clutch cover to the engine. You'll find 6 of the bolts are of this length and 2 are of this length. The 2 longer bolts go, one in the very front and one in the very back. Gently prying to release it from the gasket, you pull the clutch cover off. This is the plastic water pump gear. This gear is relatively trouble-free, although when reinstalling the clutch cover, you must be certain that you very gently rotate the impeller as you're pressing the cover on. This will help this gear to mesh with the metal gear that it rides on inside the engine. You will find 6 clutch springs with 6 clutch spring bolts, and the head of the bolt is size 8 millimeter. The 160 can be used with only 4 of these bolts and springs, although it comes equipped with 6 from the factory. When you remove the clutch plates, you will find an outer disc and 6 fiber plates. Inspect the fiber plates to make sure that the material is good on both sides. The minimum width of these plates is described in the owner's manual. Then you have 5 steel-driven discs. The innermost clutch disc, which is different than the other ones, is called the mixed disc. It looks like the steel discs but has fiber on one side. The fiber faces the inside of the clutch basket. Then it's followed with a fiber disc, then a steel, then a fiber, and so on. If you find it necessary to remove the basket, you will find this valve-shaped push rod can be removed and set aside. You have a folding washer over the nut, and you remove this nut and the clutch basket comes off. An air tool may be required here, an impact wrench, to loosen this nut. When reinstalling the clutch plates, you will find that on these 6 posts that the spring bolts thread into, one of the posts has a small groove notched in it. You can see it right there. This post lines up with the cast-in marking on this cover plate. So when you reassemble it, you want those 2 lines to match. This mark will be found directly above the part number. You can use a clutch hub holding tool to hold this hub in position while you break the nut loose, but an air impact wrench also works very well. There we have it. You'll find a flat washer, 2 needle bearings, and a sleeve. It's best to lay these parts down when you're working on your bike so that you can remember the order in which they went back together. This is the shifting drum. When you operate your shifter lever, this claw mechanism, which is connected to this arm here, and this being your shifting pivot shaft, the claw rotates the drum and puts the bike in the gear. You'll see here the small detent ball falls into this slot. That's neutral. First gear is forward, second, third, so on. This rivet right here that holds this claw arm to this plate is designed to yield if you strike a large object with your shifter lever, like a rock. This rivet will pull out of this part. Your bike will be temporarily engaged in only the gear you had selected at the time, but this fail-safe, proven part here costs very little to replace and will prevent internal transmission damage if the occasion of your shifter striking an object should happen. To repair a broken shifting claw, you remove the shifter from the opposite side of the engine and you just pull on the shifter shaft and you will see that the claw releases. And you have a spring here that's on the shaft. All the parts come right out. This is where your shifter attaches on the opposite side of the engine. Now, when disassembling and reassembling this mechanism, be certain that you have looked carefully at the position of the springs so that you can reinstall them correctly. When you put this back together, this spring goes like this. One side on each side of this prong. Then you put the mechanism back together. Put the spring over the post like so. There. When replacing the shifter claw, you merely have to grind this rivet and the 2 pieces separate, and you can replace this rivet piece and this claw, and your bike will work like new again. This is a magneto cover. It has 4 identical Allen head screws. After you've removed the screws, you can lift the shifter and remove the cover. here you'll find the magneto flywheel nut. This also is best removed with an air tool. To check or change the timing of the ignition, you will need a 24mm socket to remove the flywheel nut. Counterclockwise. The flywheel removing tool, which is available from your gas dealer. Threads onto the flywheel. Then by driving in this bolt, the flywheel will come off of the shaft. This is the Ducati brand ignition, now used exclusively on the gas. Formerly they used a Motoplat. The tool that removes the flywheel on the Ducati ignition is the same as the one that removes the Motoplat. As described in the printed owner's manual, this is the timing mark. This is set at the factory. You will see that the mark goes from the stator plate, which is this piece, over onto the engine. If you want to alter the bike's power to make it smoother, you will loosen these 3 Allen bolts. You will rotate the stator counterclockwise. Okay. When you move the stator plate counterclockwise, you retard your timing. When you move it clockwise, you advance your timing. Retarding the timing slightly will make your bike's engine run smoother. The amount that you can retard it is very slight, maybe only 1 to 2 millimeters of movement away from the line. Advancing the stator plate or rotating it clockwise will increase your bike's power and throttle response. If spark knock or detonation is a problem, especially if you're using just normal pump gas, you may want to slightly retard your timing. If you have advanced your timing and spark knock becomes a problem, you may wish to return it to its original position. To check the factory timing to be certain that it's correct, you will need a dial indicator gauge to insert in the spark plug hole. The factory setting for the timing is 2.7 millimeters before top dead center. You'll find on your flywheel 3 holes. The smaller of the 3, which is 5 millimeter in diameter, and this 5 millimeter hole on the stator plate is where you insert a 5 millimeter diameter rod through this hole into this hole. Then take your reading off your dial indicator gauge, and it should yield a reading of 2.7 millimeters before top dead center. If you need to alter that, you will need to slightly loosen your stator plate bolts. While reading your dial indicator gauge, you can move your flywheel, which moves the stator. Very carefully then remove the flywheel, lock the stator down, recheck your timing, and you're done. The coils on your stator are for operating your lights and generating electricity to power your fan. This box here is the pickup which fires your spark plug. This assembly is generally not serviceable. If it fails, it usually must be replaced entirely. The Ducati ignition system is extremely reliable and has been used by many different manufacturers for many years. For 1995, Gas has installed a smooth bore tube between the air box and the carburetor. This is after 2 years of testing. Now it is easiest to remove the carburetor by first loosening the 2 carburetor hose clamps and removing 2 bolts from the air box, one here and one on the opposite side down here. The air box may then be slid back just a little bit and it will let you remove the carburetor. If you merely need to change the main jet or change the needle clip position, you can remove the top of the carburetor and the slide and work on your needle, or with the slide removed, you can rotate the carburetor slightly and remove the main jet nut, which is on the bottom of the float bowl. Starting in 1994, GasGas switched to a different type of Dell'Orto carburetor. This is a dual float design, 26 millimeter. When removing the float bowl, you will remove the main jet bolt. This is the main jet right here. Float bowl is removed like this. The carburetor should be kept upright. There are two separate floats inside. The small pin should be at the bottom of the float bowl. It is possible to assemble the carburetor incorrectly so that the pins are at the top. Be certain that they're on the bottom. To adjust the float level of the carburetor, you'll see these two brass prongs. The factory setting is 20 millimeters, and that is using a straight edge metric ruler measuring from the surface where the float bowl seals to this top edge. This is your pilot jet. Down inside there is your needle jet. This is the choke jet. This is the fuel needle and seat. There is a small filter underneath the filler cover on the side of the carburetor where the gas enters. You will find this filter there. It's a disc with a screen. As you can see, there's a slight amount of debris there on this used carburetor. Periodically, this may be needing to be cleaned. It's not necessary to remove it. You can just wash it in there. Be very careful because the screen material is very delicate. You must also be certain that you do not lose the sealing washer, which is on the bolt. You may also rotate this housing to give the alignment that you choose for your fuel line. These are your overflow vents. This screw sets your idle by turning it clockwise. It raises the slide, which increases the RPM. As your bike's engine breaks in, you may actually have to turn this counterclockwise to lower the slide, as the idle may increase as the engine loosens up. This screw is the fuel mixture screw at idle. This screw regulates fuel, not air. When you turn the screw in, you cut back on fuel, and when you turn it out or counterclockwise, you increase the fuel into the pilot circuit. Standard setting is 3 to 4 turns from the inmost position. Jetting. This is something that you should discuss with your GasGas dealer. Generally, the main jet is the jet that you will change. When you go to extremely high altitude, you must go to a leaner main jet to offset the lack of air at high altitude. This main jet, which attaches to the bolt which screws into the bottom of the float bowl, is available in many different sizes, and due to thorough testing by GasGas USA, your dealer can supply you with the necessary jets to make your bike run properly at any altitude and any atmospheric conditions. The float bowl, again being kept upright, is installed. The main jet bolt threads in. Again, you have a sealing washer. Tighten securely, 14 millimeters. Your needle clip position is also factory set, and it may be altered again if you are riding in high altitude. The factory settings of your carburetor are available from your GasGas dealer, And again, do not attempt any modifications to jetting without first contacting your dealer to get an idea of the correct jetting procedure. If you feel that your motorcycle may be running too hot and you wish to check the fan and or the thermostat, an easy way to check the fan motor to see that it's operating correctly is to disconnect the two wires on the thermostat and take a little jumper wire or a paper clip, whatever, and connect the two thermostat wires together, and this will make the fan run constantly. You can also do this in an emergency if your thermostat should fail and you need to continue to ride. The thermostat, which we will show how to check it, can be removed from the thermostat housing by lightly prying outward on the two clips here, and then just very gently pulling on the thermostat. It will come out of its small gasket that it seats in. These are the components of the thermostat: your actual thermostat, the sealing gasket, and this clip and the housing. The clip goes on first, then the gasket, then the thermostat presses in and is locked in by the clip. To check your thermostat, you need an ohm meter. You will see that when the thermostat is cool, there is no circuit. Using a cigarette lighter, you can hold your thermostat with the ohm meter prongs installed and heat the thermostat. You will hear an audible click when the thermostat kicks on. You can now see that we have a circuit. When the thermostat cools, you will also hear an audible click as it returns to its original state. There. The new muffler is repackable by removing the rivets and removing the end cap. The factory recommends genuine packing material from Gas be used. A muffler needs to be repacked after the bike has been in use for a long period of time or after it begins to sound much louder. If the muffler has been removed for any reason, inspect the O-ring, replace if damaged, and when reinstalling, a high temperature RTV sealant should be used. This also applies to the juncture of the front pipe to the center pipe. The O-ring is there, and it should be inspected also anytime that the front exhaust pipe is removed. If there's any evidence of leakage, you may find black carbon traces coming out from this joint. It is critical that these joints be sealed because noticeable loss of bottom end power may result if these leak. To remove the cylinder head and or cylinder for maintenance for removing carbon deposits and to replace a piston and or rings, you must first drain the cooling system. And of course removing the radiator cap to allow the air to go in as it's draining. On the 350, you may need to release the radiator hose from the water pump cover and drain the cooling system here. To remove the cylinder and or the cylinder head, you must remove, of course, all of the components that are in the path of your operation. You will remove the front top radiator cover bolt and horn. You will find a small aluminum spacer. After you disconnect the radiator hoses, the radiator will tilt forward and lift upwards. You will notice that the hose clamps on this motorcycle are a spring type, and you can insert a small screwdriver into the clamp, and by prying outward, clamp will release, and you can remove your hoses. After removing the radiator hoses and unplugging the cooling fan, we can tilt the radiator forward and lift it out of its mounts and remove it as a complete assembly. This green wire is your fan ground, and it grounds to the mounting bolt on the silver box or voltage regulator. After removing the two front exhaust pipe mounting bolts, you can remove the exhaust pipe by wiggling it and pulling forward. When removing the cylinder head bolts, loosen them in a cross pattern. When reinstalling the cylinder head, these bolts should be tightened in a cross pattern also, and they should be tightened to 18 foot-pounds with a torque wrench. This torque specification is also listed in the owner's manual. Your cylinder head bolts have a small O-ring to seal the bolt to the head. We recommend that you replace these O-rings anytime that you have the cylinder head bolts removed. Also, a light grease or oil should be applied to each O-ring so that it does not catch when it's being reinstalled and torqued. When you remove the cylinder head, you will notice two O-rings. It's possible that these O-rings may be reusable, but we recommend that you replace them. When replacing them, put a light coating of grease on the O-ring. This will help the O-ring to stick in its groove when you're reinstalling the cylinder head. The GasGas motorcycle is designed for ease of maintenance. You will notice that your cylinder can be removed without removing the engine from the chassis. To remove the cylinder, you must remove the two cylinder stay braces, which attach from the base of the cylinder to the frame on either side. You must, using the Kickstarter, lower the piston to the bottom, and you must disconnect the water hose from the cylinder to the water pump. Once we've removed the 4 cylinder base nuts and the 2 cylinder stays, you can remove the cylinder by very lightly tapping on it to break it loose from the base gasket. Lifting upward, the cylinder comes off very carefully now so as not to damage the piston. You will see that you may have more than one base gasket. This is when the factory assembles the engine to get the correct measurements of the ports. They will use different width gaskets or a combination of gaskets. Very gently we remove the cylinder from the piston. You will turn the cylinder on its side and you can remove it from the frame like that. The cylinder base gaskets are available in different widths, and you can get specifications from your GasGas dealer to properly measure and set up your cylinder porting depth. This is where the water passes from the cylinder down into your center cases, and this is again only on the 1995 JT25 models. The cylinder base gaskets have a cutaway portion to allow the antifreeze to pass down into the center cases. To remove the piston, you will find, as on most two-strokes, a circlip that releases your piston pin, which can be pushed outward, then the piston can be removed. Anytime you're going to be removing circlips or piston parts, you must first take a rag and insert it in the opening for your crankcase, so if your circlip from your piston should drop, it will not fall down into the crankcase where it would be difficult to retrieve. To remove the piston rings, you merely slightly pry the ring apart and you can work it off of the piston like so. The top ring is an L-shaped ring, and the bottom ring is a flat ring. You will find on your piston 2 locating pins, one for each ring. The opening of the ring must be on the locating pin. When reinstalling the cylinder, you must, with your hand, hold the rings closed as you slip the cylinder down over the piston. This prevents damaging the piston rings. Or you can use a tool that's designed for the purpose of holding the rings closed. The Gas Trials motorcycle uses a Nikasil plated cylinder bore. The cylinder cannot be bored as in some types of motorcycles. Most Trials motorcycles in use today have Nikasil or chromium plated cylinder bores. If you need to have the cylinder serviced, we recommend that you see a professional familiar with chromium and or Nikasil type cylinders. It is possible to replace the piston ring, and when you fit new rings to the piston, you will need to insert the ring into the cylinder, and using the piston to center the ring, you press it down into the cylinder bore, and then you'll want to check your ring in gap. In this particular example, it's too wide. The standard for ring in gap in Gas Trials motorcycles is 0.1 or 1/10 of a millimeter per inch of cylinder bore. The 238 cylinder, which I am holding, uses a almost 3-inch bore, so we will recommend that the piston ring end gap would be 0.3 millimeters, which you can use a feeler gauge to check between the ring end gap. Of course, like I said, this is much too wide. I'm using a worn piston ring here as an example. Here we have the 3 engine sizes of Gas Trials motorcycles. This is the GT16, commonly called the 160, available in GT or JT models, depending on the year. Actual displacement, 144 cc's. This is the 238 cc model, or the JT or GT25. This is the 327 cc model, GT or JT 32 or 35. As you can see, there's a wide difference between the diameter of the pistons on the different models. Again, on our ring end gap, we take a tape measure and we measure the distance across the bore, this one being 2 1/4 inches. So at the calculation of 1/10 of a millimeter per inch of bore, we would say that the ring end gap on the 160 would be 0.25 millimeters. And since we have almost exactly a 3-inch bore, we would say 0.3 millimeters. And on the 327, we have a 3 1/4, almost 3 1/2. We would say about 0.3 or 0.32 millimeters ring in gap on the 350. After many hours of use, and depending on the type of oil you use in your premix and the premix ratio that you use, you may need to decarbon the cylinder head or the top of the piston, or both. You will find that a mild solvent like gasoline with a mild abrasive cloth like a Scotch pad is all that's necessary to remove these carbon deposits. When removing a carbon deposit from the top of the piston, again, you want to shield the area below the piston so that the debris does not drop down into the crankshaft. If the piston is ever removed from the bike for any purpose, you will notice that there is an arrow on the piston. This arrow always points to the exhaust side, which would be forward. About the premix, the factory owner's booklet recommends a 1.5% premix ratio of any synthetic or synthetic blend oil. That is a 75-to-1 premix ratio, and you may mix leaner up to 100-to-1 if you choose. If you mix richer, the oil deposits may build up on your piston and cylinder head and in the exhaust system, causing you to prematurely need to take apart your engine and exhaust system to clean out those deposits. A trials motorcycle, which is operated mostly at low RPMs, does not need as much oil in the gasoline as the racing type two-strokes that you may be familiar with. After removing this large bolt, the swing arm linkage arms, or dog bones, can be lowered, and then raising the swing arm slightly will give you access to the bottom shock mounting bolt, which is here. This bolt must be very tight. It uses a size 8mm Allen. This bolt here, which is a size 13mm wrench, must also be kept very tight in addition to the large bolt. If you detect any play in your rear suspension linkage, it may be a problem as simple as a loose mounting bolt. For clarity, we have removed the linkage pieces and shock absorber and reassembled them for you to see how the mechanism is assembled. This is the lower shock mounting bolt. Again, an 8mm Allen wrench removes it. This center linkage piece, the two dog bones. This part attaches to the swing arm. It has two cage needle bearings and two oil seals, one on each side, and the 13mm wrench. This is your large suspension pivot bolt and the two dog bones. The 8mm wrench again is used to remove the large suspension pivot bolt. This is your dog bone. It has needle bearings inside and an oil seal on each side to keep water and dirt from entering the bearing. These bushings, there are two types. This one, which fits the larger bolt, and a very similar one on the opposite end, which fits the smaller bolt. When taking this apart to grease the components, you must inspect thoroughly the needle bearing to make sure that it is intact. Also inspect the surface of this bushing. Sometimes when your suspension parts become worn, these bushings and needle bearings will transmit to play in your rear swing arm, and if that's the case, they will need to be replaced. To replace the needle bearings in the dog bones, you can drive them out with a socket that is of the suitable diameter. Also, there are optional needle bearings available which have oil seals built into the bearing. See your gas dealer for a choice of the optional bearings that you may use.